Okay, just want to take a minute today and go over how this set bit function works in the IEC 61131 instructions. So what we see here on the screen is the set bit function, and we'll go over each of the parameters involved with this function. So the first parameter is the set bit in that I've defined, and I've just defined that as an integer. You can define this as any data type you want. If you want to do a double integer or a signed double, whatever you like. So the key here is that the input to the function has to equal the output. So you've got an input and an output, and typically it's going to be like an integer or a word, something like that, because you're going to be, the reason that you use this function is so that you can manipulate bits within a specific data type. So this is your input, this is the output. This variable that you see here is actually setting which bit in your variable you want to manipulate. So it starts with position 0 of the variable. So you can go from, if it's a 16-bit register that you're manipulating, you would be setting this value for anywhere from 0 to 15, depending on which exact bit you want to configure. And then this variable here is actually setting, do you want to set that bit to on, or do you want to set it to an off position? So we'll go ahead and simulate this function. So we can just go to mode and then start simulation, and we'll just do logic only. So that'll compile this, and it actually allows us to configure and change settings here. So if we go ahead and don't change our input variable to anything, we can say set bit. If we say set bit 4, that's going to change the fourth. It's actually going to be the 5th position of the variable. So we'll just force this. And now you see the output hasn't changed at all. But now if we say set that bit to true, we could see that that changed to 16. So this is basically how it works. If you have different variables or different bits that you're going to be wanting to set, you would have to, for example, if you have a 16-bit register, then, and if you want to manipulate each of those bits individually, you would have to have 16 individual of function blocks. Each one of them would be manipulating variable or the bit position anywhere from 0 to 15. So the first function block would be bit 0, the second function block would be bit 1, and all the way through to bit 15. So hope this has been helpful, and you get an idea for how this function works. And then the other thing that you have here is just an output, and you could choose to use that, or you don't have to even use that. One more thing that I would show you here is, we'll go offline here. With any of these functions, you can switch this over to a structured text expression of the function. So I could go to Tools and go to Convert Program, and I can say I want to convert the latter to structured text. So in order to do this, there cannot be any errors or compile errors. So I know that there's no compile errors here, so we'll go ahead and convert this to structured text. So it just gives me an information: the project must be built without errors before converting program. So do you want to continue? We'll just say yes. And so this is the expression of the ladder function that we just saw. So all the same variables are in here, and it's just basically going to do the same function. So again, we could do a start simulation, logic only, and this will allow me to change any of these variables. So if I want to change one of the variables, what I can do is I have to hold down the shift key and then double click on the variable itself. So now I can change this value. So if I change the value coming in to 16, the output is also going to be 16. Now if I want to turn a bit on, let's see, so I can change the set bit. So if I want to change bit 0, so I'll force that to 0, which it already is, and I want to turn on bit 0, I again hit shift and double click this, and I set it to true, and you can see the output then changes to 17. So the input is 16, and because we're turning on the first position of the register, it sets this to 17. So again, we can just double click this, we can say false, and it will change this back to 16. So hope this helps. Thanks.